Particle physics at the moment is at a really fantastically exciting stage. We just had this phenomenal discovery of the Higgs boson, something that we've been thinking about, dreaming about for 48 years.
And so you could think, oh, that's the end of the search, that's the end of the journey. We now are happy with the standard model and we can stop. But it has also triggered a lot of new questions.
Now we need to be clever enough to go further in this quest of unlocking the secrets of nature.
To repeat history this time, we want to be even more ambitious because we have no idea what's the new scale ahead of us, and we want to probe really tiny effects in this beautiful standard model that up to now seems to describe everything in the world of particle physics.
The next step is to look beyond those known particles and try to get some hints as to what might be the masses of unseen particles.
The answer to this question calls for new physics. As we will see, Tlep can address a number of questions about the standard model in a very unique fashion.
So Tlep is an electron-positron machine. The name comes from triple Lep, so it's going to be 3 times the size of Lep.
An idea of building a large machine, much larger than everything that we had before. It would be 3 times the diameter of the LHC, more or less 100 kilometers. That would be here around base at CERN.
For studying interaction in a wide range of energy from 90 GeV up to 350 GeV.
Why is the Tlep project revolutionary? Because with the new technologies we have at hand now, we are able to produce luminosity, that is the rate of collision, which are 3 orders of magnitude larger than any other project on the market so far.
We're able to know where the beams are in a much better way than we did before. We're able to squeeze the beams more than we did before. And generally speaking, we just profit from the fact that 30 years have passed and technology has progressed.
We do believe that the experience that scientists in the last 50 years gathered on Silk machines can actually be profited from in order to deliver stable high luminosity operations.
And this offers all sorts of exciting new possibilities for precision measurements of the fundamental parameters of the standard model.
So effectively Tlep would be 2 machines in one. One part would be a Higgs factory.
Tlep will be able to measure the coupling, the properties of the Higgs boson to a per mil precision.
But the other would be constraining the electroweak parameters of the theory.
We'll be able to improve the precision on the Z boson and W boson properties by several orders of magnitudes, which is just fantastic today to think of it.
Tlep was proposed as a first stage of a much wider endeavor.
Then in the same tunnel, later we would put a proton collider using 16 or 20 Tesla magnets to go up to 100 TeV in the center of Mars or beyond.
One of the great virtues of this idea of having one great tunnel and then one electron machine and then one proton machine is that it is quite economical.
In fact, there is an enormous synergy between these machines. The Tlep would provide the tunnel, the cryogenics, some of the magnets, the base detectors, and all the infrastructure, surface buildings, electricity, cooling and ventilation that are later needed for the Hadron Collider.
So I think that the 2 of them, they do make a very strong physics case, and I really think that the scientific community should really look into these 2 projects and actually start thinking about those as probably the most beautiful and most appealing options for the future.
This ambitious project will require a lot of work and innovation and ideas from all the fields in particle physics.
More than 300 physicists from more than 70 institutes out of 24 countries and 5 continents have signed up the design study.
This number is steadily increasing with contributions from all around the world. We can be many more, and when it will come to build detectors, to build the accelerator, to build the extraordinary facilities that we need to have to make all this dream come true, we will need many, many more people.
So of course we're very happy when somebody comes and joins our study group, and we encourage all of you to think about the exciting prospects of a new machine that could operate in your lifetimes.
It's very important to start thinking now about what we, the world particle physics community, would like to do next. And it's very important to get that choice right.
In this time of crisis, it's always very difficult to propose new projects of this size.
It is indeed true that an 80-kilometer tunnel is extremely challenging from several points of view.
However, we should remember that we are physicists first.
You know, thinking big is probably the best way to go forward.
We do think big, and we also try to think clever.
There is a lot to do, and we are a very fun team to work with.
So, jump in and join us.